Hello everyone, I am Ronaldin D. Esplana and I will discuss about the weighted graphs. There are two types of weighted graphs. The edges are assigned a weight or weighted edges, and the vertices are assigned a weight or weighted vertex. So let's proceed to the weighted edge graphs. In a weighted edge graph, each edge has an associated numerical value called the weight of edge. Edge weights may represent distance, cost, and etc. For example, in a flight route graph, the weight of an edge represents the distance in miles between the endpoint airports. As you observe to the graph presented, there are oval shapes with the letters inside and the line segment with the corresponding numbers. The oval shapes are the vertex, and the line segments are what we call edges. The letters represents the airports, while the numbers represents the weight of an edge or the distance in miles between the endpoint airports. So we have here an example of a weighted graphs, and we're going to determine which is the weight and which is the vertex. We're also going to determine how can we make a conclusion based from the graph itself. So when we say vertex, it is the endpoints of the graphs. Vertex, 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 vertex. So when we say weight, it is the numbers corresponds to an edge. Kapag sinabi naman nating edges, it is the line segments of the graph. 1, 2, 3, 4, 5, 6, and 7. So since nahanap na natin ang weights and vertex of the graph, proceed na tayo sa conclusion. So in making a conclusion, we're just going to make a tally regarding the graph. So, ang format ng conclusion is vertex, vertex, and weight. So we have here the conclusion of the weighted edge graph presented before. So edges is equals to close and open parentheses, vertex, vertex, and weight. We must take note that in writing the conclusion of the weighted edge graph, the first vertex to be written should be arranged from lowest to highest. So now let's proceed to the weighted edges in an adjacency matrix. An adjacency list is an array of A of separate lists. Each element of the array A is a list which contains all the vertices that are adjacent to the vertex I. For a weighted graph, the weight or cost of the edge is stored along with the vertex in the list using pairs. In short, the adjacency matrix is the table or the list of the vertices and the corresponding weights of the edges. So we have here an example of a weighted graph, and we're going to make an adjacency matrix based on this. So first we're going to make a table. Write V1, V2, V3, V4, V5, and V6 since we have 6 vertices. Next, write V1, V2, V3, V4, V5, and V6. So first, we're going to determine the weights of the edges that connects to the vertex. So V1 to V1 is 0 because it is not connected to itself. So we're going to put 0. Next, V1 to V2, V1 to V2, and the corresponding weights is 2. V1 to V3, it is not connected directly to the V3, so we're going to put 0. V1 to V4, it is connected to V4, so we're going to put the weight 4. V5, V1 is not connected directly to V5, so we're going to put 0. V1 to V6 has a weight of 8. So since tapos na sa horizontal side, just copy to the vertical. 2, 0, 4, 0, 8. Kasi pag hinanap mo to dito, parehas lang naman. So next, proceed to vertex 2 to 2. So since vertex 2 is not connected to vertex 2 directly, we're going to put 0. V2 to V3 is 5. V2 to V4 is not connected directly, so we're going to put 0. V2 to V5 is connected, so we're going to put number 3. V2 to V6 is not connected directly, so we're going to put 0 again. So just copy the horizontal to vertical. 5, 0, 3, and 0. Next, V3 to V3 is 0 because it is not connected to itself. V3 to V4 is 7. V3 to V5 is not connected, so we're going to put 0. V3 to V6 is connected and has the weight of 3. Just copy again. Next, V4. V4 to V4 is 0 because it is not connected to itself. V4 to V5 has the weight of 2. V4 to V6 is not connected directly, so we're going to put 0 again. Then, copy. V5 to V5 is 0. V5 to V6 is 6. Copy. So, V6 to V6 is 0. So we have here the adjacency matrix of this example. So that is the adjacency matrix of the weighted graphs. So what we are going to do now is to present the answers in a more clearly stated table or list. So that was all the discussion of Group 3 for today. The main topic of the Group 3 is the mathematics of graph, and the subtopics are graphs, Euler circuits, and weighted graphs. The group is composed of 9 members, which is Ronilyn Esplana, John Ray Escario, Sherilyn Espinol, RJ Estur, Jaira Estoperez, Joan Espinida, Jessel Estera, Carl Michael Espinida, and Mark Carl Escarcha. Thank you for watching and for listening. Have a nice day, guys!